Hey, welcome back. This is homework for exercise 2. So, firstly, we are informed that the random variable x is uniform in the interval from -1 to 1. So, based on the definition of uniform distribution, we could write the density function and distribution function of random variable x. So here that is density function. Since it is in the interval -1 to 1, so here should be 1/2, and from -1 to 1 and 0 otherwise. Zero from -1 to 1. Right. For the distribution function, we could also simply get this. Let me draw the figure of that. From -1 to 1, that is here to here. Here is 1. Right. And we are given that the density function of y is equal to this. So we are gonna to find gx such that the density function is equal to this, right? So from the density function, we could use integral to get the distribution function. So here there should be -infinity, but there is a step function, so I just replace the -infinity to 0 here. And so the distribution function of y is equal to this. And here should be a step function, right? Yeah, I just omitted it. So if we have a gx, and we could get the density function from gx, so there must be some point that the distribution function of one random variable x is equal to this, right? Since y is a function of x, so that should be true at some point. So we could get some point to solve this equation to get what we want. So maybe we could get a point from when x is between 1 and -1 and 1. The distribution function of x is equals to x plus 1/2, and equals to the distribution function of random variable y here, so that is 1 minus over with the power of -y. And we could just simply solve this equation here. So gx equals to minus x plus 1/2, and we take log here x. So gx equals to ln 1 minus x/2. So why we take the interval that -1 and 1 here? That is because when we could see here, when x is equals to when x is smaller than -1, that is a specific value, and so it's here. So from the specific value, we just cannot just simply get the gx functions expression. So we need to take a expression with x here, but not the specific value. So based on the expression of x equals to the, that is distribution function of y here, we could solve the expression of gx. Otherwise, since y equals to gx here, right? So if the left of the equation here is a basic value of, so you only can solve that. You only can get that gx equals to some basic value here. So that is not an expression, and it is not what we want. So that is why we take the x is between -1 and 1. So that is the point of this question. Yeah, I think that's enough. That's it.